Now we're going to look at another example, total area, and we're going to compare that to the definite integral, which we've had a decent amount of practice with so far. So first, we're going to calculate the definite integral from x equals 0 to 2 pi, and then we're going to calculate the area between the graph and the x-axis from x equals 0 to 2 pi, and we're going to compare those two. So for part A, my definite integral, that's going to be the integral from 0 to 2 pi of sine x dx. And we know the integral for sine is negative cosine. So we have negative cosine x, and we need to evaluate that from 2 pi to 0. So here we would have negative cosine of 2 pi minus negative cosine of 0. And 2 pi and 0 are equal to the same value, so negative cosine 2 pi minus negative cosine 0. Cosine of 2 pi, that's negative 0 plus 0, which is 0. So the definite integral here is equal to 0. Okay, so what is the area though? Let's think about this. If we want to calculate the area, well, we have to consider the graph. And we know what the graph of sine looks like between 0 and 2 pi. All right, part of that is above the x-axis, and part of that graph is below the x-axis. And what we know is that the integral of the region above the x-axis is going to give us a positive value, and the region of the area below the x-axis is going to give us a negative value. And because this is a symmetric function, it makes sense that those two areas canceled out and gave us the definite integral is equal to 0. So if we want to calculate the area, we need to consider, well, where does this graph cross over the x-axis? And we know that occurs at pi. So in order for us to calculate area, we're going to have to say the area from 0 to pi of sine x dx plus, we're going to do absolute value of the integral from pi to 2 pi of sine x dx. And the reason we have to use absolute value here is because we know that's going to be negative. Now, it's pretty common when we're setting this up to just write the absolute value everywhere for each piece to say, hey, we know whatever we get here is going to be positive. But in this situation, because I know that I'm going to have a positive value for that first integral, I'm just going to go ahead and leave that off. So let's calculate this now. Again, we know that the integral of sine is negative cosine. So I have here negative cosine x evaluated from pi to 0 plus the absolute value of negative cosine x evaluated from 2 pi to pi. Okay, so right now I'm using these bars in here. Sometimes that's why they use brackets at the end of these. It's just a notation-wise situation or opinion here, and as long as you know what you're doing and you understand what your notation means, you're going to be okay. So for the first piece, I end up with negative cosine of pi minus negative cosine of 0 plus whatever I get for this other piece. I've got negative cosine of 2 pi minus negative cosine of pi. All right, so cosine of pi is -1, so I have negative -1 minus cosine of 0. So cosine of 0 is +1. And simplifying that, that's +1 plus 1, I end up with 2, plus cosine of 2 pi, again 1, so -1, minus cosine of pi is -1. So now note, we have this negative in front, and we're doing cosine of pi, which is -1. So inside here, I have -1 minus a +1, which is -2. Of course, we're dealing with the absolute value of that, so that is 2. So I have 2 plus 2, and I find that the area under the curve, between the curve and the x-axis, is actually 4. So again, just thinking about that sine curve, we got a +2 for that area and a -2 for the area. But we can't have negative area, so we absolute value that, and those 2's add up to give me 4 for my area. However, the definite integral, the integral is 0 because those two areas cancel each other out. So I hope we can see a difference here between area and a definite integral.